Hey, yeah. So my name's Matt Mackay. I'm also an imposter at Aspect Development. I've worked in various areas of developer experience and as a tech lead for building infrastructure teams, and orchestrated large Bazel migrations and rollouts. As well as Aspect's Bazel rule sets, I've also helped to maintain some of the open source rule sets in the Bazel org, such as rules Python and I guess the now less so rules Node.js. So today I'm going to talk about rules Py, a Python rule set for Bazel, and how it differs from rules Python, and why you might want to use it. Okay, so what is rules Py? Well, before we dive into what rules Py is, let's answer a slightly different question. What isn't rules Py? So currently, rules Py is not a full rules Python replacement, and we'll go into the details a little later on, but I just wanted to make that clear here. All right, so what is rules Py? So rules Py is a layer on top of rules Python and provides a more idiomatic approach to running Python under Bazel. We'll go into this later too, but if you've used Bazel and Python before, you know there are quite a few gotchas. Rules Py provides full Starlark implementations of the Python rules, like PyBinary, PyLibrary, and of course PyTest, as well as a few of our own rules that complement the rest of the rule set, such as PyVM. So yeah, as I mentioned, rules Py is this layer on top of rules Python. And currently makes use of the Python interpreter toolchains. So you can still use the Python Hermetic interpreter toolchains that are provided by rules Python, or you can, of course, build and register your own, like whatever you do now. We also still use the existing pip pars and other external dependency management in the exact same way. So third-party dependencies are still fetched via those rules. Mostly, I should say here. Rules Py has first-class support for wheels, but you can still plumb the rules Python external dev rules into it. Currently, we still use the same Gazelle extension too. So if you generate and manage your build files with the Python Gazelle extension, you can still use that in rules Py. However, again, I've put a little asterisk here. We may fork that soon, just so we can better support some of rules Py's own features. And help to improve the performance that we've noticed in much larger code bases. So I keep mentioning this like idiomatic approach. What do I really mean by that? So rules Py makes use of Python virtual environments. I've kind of hinted at that already, which are a more native Python construct. Our philosophy here is to try and meet the tooling where it is. So instead of trying to teach all the different ecosystems tools to work with Bazel, rules Py integrates with the existing tooling. Among other things that we'll see in a moment, rules Py removes the requirement of having a dependency on the system interpreter, as we currently use Bash launcher. But again, I guess that may change because we now depend on Bash. So as I mentioned, we make use of that Python virtual environment. Let's take a look at that. So if you aren't familiar, a Python virtual environment is a sandbox-like environment that contains the required Python interpreter, the one from the Bazel toolchain. And it also contains only the required dependencies that you requested from the target. So it's completely isolated from other Python projects in your repository or on the rest of your system. So it's kind of akin to Bazel's sandboxes. They're considered disposable. They're quick-ish to create and destroy. So using this virtual environment allows rules Py to not have to meddle with the Python path at all. The Python path is just a way that Python finds dependencies via import statements. And instead, we use that slightly more native approach that we create a site packages folder, and the normal resolution kind of takes over. The other thing it also removes is it allows us to run the interpreter in isolated mode. This one removes the current working directory from the first part of the sys path. So the moment you run like a Bazel test, the current current rule implementations kind of break out of that sandbox. So as this other consequence of like this meet the tooling where it is approach with RulesPy, RulesPy can add IDE support to existing Python, Bazel Python projects. We can generate a virtual environment for different levels of granularity, such as like a single Py binary or like an entire project, and have like the existing Python extensions for IDEs pick up those virtual environments. Like they already know how to configure the IDE with that virtual environment. Bazel's just generating it. It's the same Python interpreter that you declared on the toolchain, and it's the same dependencies that Bazel manage that end up in that virtual environment. So then features such as like go to definition, autocomplete, and other existing tools that run inside the IDE can just kind of work natively. So yeah, as I mentioned, RulesPy is that layer on top of RulesPython, and includes Starlock implementations of PyLibrary, PyTest, PyBinary. These are also exported as structs, so like the rest of our rules. So if you need to extend them, it's slightly easier. Although I think we've seen now that there might be something else coming. I should also mention here that there is ongoing work to Starlockify the existing rules. But this is still like the underlying implementation of how they work is still like tightly coupled to like how Google 3 do Python. So you can consider this like, just another approach of how to do Python rules. So changing the existing rules may be trickier to change than just turn them into Starlock. So yeah, as an extra feature that I want to mention and call out up from RulesPy is this thing called virtual dependencies. This is where a PyLibrary can simply declare a dependency on a library, like an external third-party library, but not at any particular version or be tied to any kind of label. Then the consuming PyBinary or PyTest is then required to actually provide that dependency. This can be super useful for supporting multiple versions of the same dependency. Either that's how you do dependency management, or like during a migration of like one version of Django to another, for example. There's a huge amount of stuff to unpack around virtual dependencies, but a very quick example looks something like this. So you've got like a PyLibrary at the top that you're kind of familiar with. I don't know what it is, something to do with Django. It has the name and sources that we're all familiar with. But then there's this extra attribute at the bottom where we just declare this dependency of Django. Like we don't know what that is. But then at the PyBinary level, again, we've got the normal things. Like it's probably a very small Django app, but we have our sources and our depths on our PyLibrary. But then we've got this resolutions field. And here it's where we have to replace that Django string, that like opaque Django string, with something more concrete. And at this point, we're supplying version 424 of Django. So when I would run that PyBinary, I'd get version 424. You can imagine like another PyBinary next to it, like with a completely different version, just overriding that Django opaque token. So yeah, RulesPy is, again, another asterisk, almost at version 1.0, where we're happy with the API. We've fixed a whole bunch of bugs and, well, mostly around virtual depths. We hope to publish the final 1.0 very shortly, so we do encourage you all to give it a try. RulesPy does support a more incremental migration path. It should be just as simple as just replacing the load statements for your existing PyUnderrules. We support, like, I don't want to call it a sandwich, but the like RulesPython sandwich where you go from like a RulesPython PyLibrary to a RulesPy one and back again. There should be interoperability there. We also recommend for even like better integration, we do recommend using a pure wheel setup where possible. RulesPy will make, like I said, it's got first-class support for wheels. So yeah, yeah, that's everything. Thank you very much.